Professional and Educational Activities Subcommittee, IEEE Power Energy Society Young Professionals, and I'm Shah Faisal. Today, our guest speaker is Dr. Alireza Soroudi. Dr. Alireza is an assistant professor in University College Dublin, Ireland. He is the associate editor in IET Generation, Transmission and Distribution, and IET Smart Grid Journal. He is expert in the field of power system optimization, and he is also the author of one of the famous book, Power System Optimization Modeling in Games. Today, he will talk about application of commercial and open source tools in power system optimization. So please welcome Dr. Alireza for further discussion on the topic. And thank you for joining us and giving us time today. Thank you.
Okay, thank you very much for this nice introduction. Let me share my screen and go through the slides all together. Can you see my screen now?
Yeah. Yes.
Okay, thank you very much. So the title of this talk will be the application of commercial and open source tools in power system optimization. So my name is Alireza Soroudi. I am an IEEE Senior member, and I work as the lecturer in the School of Electrical and Electronic Engineering, University College Dublin. So let's start with this beautiful slide. What we want to know, what is the meaning of the optimizations? We want to make sure that we are trying to achieve our best using our limited resources. So here in this heat map, you can see the potential of allocating offshore wind farms in the system. So you see that some areas will have more wind, some of the areas will have less wind. And the question is, how can we allocate or let's say offshore wind farms? So for example, if we focus on some area in the west of Ireland, for example, these are the areas that we can put, for example, or offshore wind farms. So there should be some constraints needs to be taken into account. For example, the distance between the wind farm should be more than some specific values in order to avoid conflicting with each other and physical damage. And also we need to minimize the cost associated with the wiring and also the work required for putting these offshore winds in the sea. And also we want to maximize the total energy we can harvest from our offshore wind. This is a very simple example of what type of optimization we are facing in reality in power system. Okay. And also let's go forward. These are the constraints that I was talking about, the wake effect. If these wind turbines are very close to each other, they will influence the production level of each other. The wiring cost, wind harvesting issue, and network capacity is also needs to be considered. For example, some areas will have a lot of wind, but the network which is connecting these offshore winds to the remaining of the system is not capable of absorbing this amount of power. So this means that we need to consider all these factors together and try to optimize our decisions. Okay, so this is a very simple example, but very practical one and very applicable in these days of power system operation and planning. So let's talk about the positive and negative issues related to the commercial and open source one. So if we talk about the commercial ones, the cost is the main issue, and they are designed for some specific purpose application. But the good thing about them is that they are coming with the convenient amount of support. So since you are paying for the license, and there are some dedicated resource right there in the companies that they are providing the software to you, so you can use their help and support to overcome the technical issues that you will face in your applications. Okay, so some of these tools are listed as here. So for example, actually OpenDSS is an open source, and DixIsland is a commercial one, Plexus commercial one, Homer, GAMS, NetPlan, PSSE, and each one of these softwares are able to do some specific work for you. For example, Plexus is capable of doing a larger scale unit commitment problems. It also is capable of handling some versions of the power flow as well. And also DixIsland is dedicated to the power flow studies, fault analysis, and different other things. Okay, so each individual one is referring to one specific topic or one or two specific topics. Okay, and the flexibilities that you will have with them is the one that is provided by the software developer to you. Okay, so if you want to have more flexibilities, if you want to be able to model some specific type of constraints that do not exist in the commercial softwares, you have to develop your own code. Yeah, so this means that you need to have more flexibilities to do the coding. For example, if you can have access to the open source ones, they are free of charge, but it takes a longer time to develop your code, and also you will have less support. So if anytime you face with some errors, you need to have access to the guidelines they usually publish with these specific softwares. And also maybe you can go to a Stack Exchange or some platforms, so everybody who are familiar with that can come and help you if they want, but there is no guarantee for that. Okay, so I can name some of them here. For example, Julia, Python, C++, Java, or some other kind of programming languages. Okay, so there is not big difference between them. It only matters how you are familiar with them, and each of them will provide you big levels of flexibility to you, but you need to be very good at each individual one if you want to do the good kind of programming practice. Okay, so let's go forward and see what do we have. So here you can see this is my book. These are the chapters related to each topic of the power system optimization. Actually, some of them are covered here, like economic dispatch, unit commitment, dynamic economic dispatch, AC/DC OPF, multi-period AC/DC OPF, energy storage, observability of the system, transmission, operation and planning, and also energy system integration. Okay, so all of these topics can be tackled using the optimization tools, and we will see here some of them in this session. So we can face with different types of optimization, like single objectives, this one. So we have one objective function, we have a set of constraints, we want to consider them in minimizing or maximizing our objective function, or we can have more than one objective function, and we want to minimize or maximize both of them, or minimize one or maximize the other one, like minimizing emission, minimizing the cost at the same time, maximizing the reliability, minimizing the cost at the same time. Or sometimes the objective one or two of the objective functions are inside or constraint. So we want to make sure that the maximum value of OF2 is less than something. At the same time, we want to minimize our cost, for example. Okay. So these are all the types of the optimization problems that can be formulated and solved in the optimization tools that we want to discuss today. So I have tried to model the steps of the optimizations. So we have 4 different elements. It's you who are doing the coding. This is your problem, and this is the tool you are going to use, and this is the solver. So let me explain each individual one. So this is you know yourself better. It's not needed to explain it. So always we need a human to describe the problem that we are facing with it to optimization tool. So what does it mean? It means that the optimization tool doesn't understand physics. It doesn't understand chemical engineering. It doesn't understand business. So it only understands mathematics. So you should be able to describe mathematically your problem for the optimization tool. And this is not the optimization tool that is going to solve your problem. This is the solver who is going to solve your problem. Okay, so the solvers are different in the market. So for example, CBC, GLPK, IPOpt, Groovy, Cplex, and there are multiples of other solvers in the market. Okay, some of them are open source, some of them are commercial ones. So when we talk about the commercial tools, let's clarify what are we talking about. So here, the white boxes are the open source solvers. So it means that if you want to solve, if you want to use them for your problem, you don't need to have any specific license. But some of them will require some licensing issues. So for example, Groovy and Cplex are providing some license for the academia, but if in the industry they want to be used, and you need to purchase their license based on their terms and condition. So so this means that if we want to use the commercial ones, we have to pay for the licenses. Okay, and at the middle of the problem and the solver, there is a tool here, which can be an open source one like Pyomo, or a commercial one like GAMS. Okay, so if you want your problem to be solved by an open source tool, you can use Pyomo and solve for free. But if you want to use GAMS and use the open source one, then you have to pay the license for the GAMS. If you want to use some licensed solvers with the GAMS, then you have to pay the license for the GAMS and the solver, So as simple as that. So what is the role of this tool at the middle? It is trying to translate your problem for the solver, okay? That's the role of my optimization tool here, which can be a Pyomo or a GAMS. So it's basically these two famous tools, Pyomo or GAMS, are kind of solver agnostic tools. It means that they just receive your problem and then they will translate it for the solver. You might ask me, is it possible to directly talk to the solver itself without using Pyomo or GAMS? The short answer is yes, but how you are going to do is a difficult one. But how? For example, if you want to use the Cplex directly without using Pyomo or GAMS, it means that you have to go and learn the language of the Cplex. If you want to use Groovy, then you have to go and learn the language of Groovy or IPUP or GLPK or CBC or whatever, okay? So in this way, you have to learn 5 different coding languages. But if you want to use only single one, you can go for these tools, okay? So if you learn their language, they will translate your problem to the solver. And that's as simple as that. Okay, let's go forward. And always you need to make sure that you are using the right tool for the right problem. So you can't use the solvers that are designed for linear programming and use them in the nonlinear programming. So you need to know, first of all, what is the type of your problem? And then you need to know each individual solver is capable of solving what type of problem. So for example, CBC is capable of solving linear, mixed integer linear programming, GLPK the same, IPUP solves linear, nonlinear, and Groovy and Cplex will solve all the types other than the NLP one. Okay, so it's always needed that you understand what type of problem you are going to solve. Okay, so so what can be done with these tools? So you are all, I can assume that you are all power system engineers, and you are facing with different types of problems like OPF, unit commitment planning, integration, energy system integration, uncertainty modeling. So is it possible to just drop these problems into the Pyomo and GAMS and ask them to solve it for you? The short answer is no. Why? Because there is a need for an expert, which is yourself, and that expert should use mathematical language to describe these problems for the Pyomo or GAMS. As I already mentioned, these two are not engineers, these softwares. They are just mathematicians, okay? They just understand the language of math. So you need to use the different equations like constraints, like objective functions, like limits for your variables to specify what are the constraints are governing my optimization problem, and then pass it to the optimization tool, which can be Pyomo or GAMS, and then they will show you the key for the problem. They will provide you the solution for that. They will provide you the optimal solution for that, okay? So what are the elements of my decision making? So here you can see there are different elements in each individual Pyomo code. They can be constraint, set, parameters, variables, and the data, okay? And then once you are finished with the optimization, the solving of the optimization problem, then you can pass it to your visualization tool and also the solvers, okay? So the solver will receive the problem from the optimization and they will pass it to the visualization tools. So the visualization tool and also the solver are not part of the Pyomo package. They are something in addition to that. So the beauty of using Pyomo for solving the power system or any type of optimization problem is that you are capable of and you do have the freedom of using different visualization packages or data analytic packages that are available in Python, which is not the case in GAMS. So if you want to do the same action in the GAMS, then you need to solve your problem, extract the solution from your GAMS model, pass it to Excel or something else, and then continue your work with the other packages in Python, for example. But if you do it in Pyomo, then everything is done in Python, and it's for free. if you use the open source solvers. Okay, so let me show you some more details regarding this issue. So as I said, each individual model has different elements. These are the 5 elements: set, variable, parameter, constraint, objective. So, and also we'll pass the result into the solve statement, and the solve will call the solver and solve the problem for you. And finally, the visualization piece. So if I want to give you an example regarding the sets, for example, set of generating units, generation unit 1, 2, 3, 4, 5. And the variables can be, for example, the output of each individual generator. If you want to say individual generator, you need to define it over the set of generating units, for example. You can also specify some bounds for your variables. And also you need to specify, is it a binary variable? Is it a real variable? Is it a positive one? Is it a negative one? So you can specify all these things. These are the different types of the variables that you can have. For example, real, binary, integer, and different other flexibilities are available here, you see. So depending on your model, you can use any of them that is suitable for you. And also, as I said before, this is another factor which is important, which is creating the data of the problem. Means that, for example, the demand at each individual bus, the Vmin and Vmax for each individual voltage at each individual bus, and also the line limit, for example, or different other things, the ramp rates, anything that you know beforehand, before solving the problem, the optimization problem. And then it's come to constraints. So constraints are describing the relation between the variables and also the data that you have. So for example, summation of the generation should be equal to the demand, or change between generation at 2 consecutive time period cannot exceed some value, which we call it ramp rates, for example. And finally, the most important one is the objective function. So it means that we need to specify what is the value that we want to minimize or maximize. Yes. So we need to define some rule for that and tell the Pyomo or GAMS or whatever tool that we are using, this is the expression you need to minimize or maximize. And you can see here there are some variables inside my objective function, and the solver will try to tune the value of the variable in a way that the sense of optimization is realized. Is it maximization or it's a minimization? Any of the case will be solved. And finally, we will pass it to the solver. So depending on the type of or optimization model, we have to use the right solver, as we discussed. If it's nonlinear, we have to use IPOpt. If it's linear, we can use GLPK, we can use Cplex, Groovy. And finally, we can do the visualization. There are multiple visualization packages in Python. You might be familiar with them, like Bokeh, like Plotly, ggplot. And the most famous and the most easiest one is Matplotlib. Maybe some of them have more capabilities, but not as straightforward as the Matplotlib. Okay, so it doesn't matter which one you use, as far as you can visualize what you have created, that's fine. So you should be able to send a message out of your optimization problem. And for example, you can create some nice graph like this and show the results of your the output of your optimization problem. This is, as I said before, this is not something inside the Pyomo package. This is something inside the other packages. So we'll receive the output of the Pyomo, pass it to the next package, and we will do the work from there. So let me show you an example. This is a very simple optimization problem: 3x1 plus x2 subject to 2 linear constraints. So these constants will create my parameters, and also these are my variables, for example, x1 and x2. And this is a constraint, this is another constraint, and finally this is my objective function. Okay, so we want to know how can we code it in Pyomo, for example. As simple as that. So for example, at the beginning we have to call the Pyomo package, and we import whatever is inside my Pyomo package, which is installed on my machine, and then define an abstract model or concrete model. It doesn't matter what's the difference between them at this stage. We have to define 2 decision variables, x1 and x2, for example. We can initialize them. We can say they are always non-negative reals. And then I do have two constraints. You see, model 2 multiplied by x, model.x1 plus 3 multiplied by model x2 is less than equal to 4. And exactly similar thing should happen for the other constraint, which is C2. And we have to define our objective function, which is a very simple one, as follows, and set the sense of optimization, which is the maximize. And then once we finish this tab, they are all coded in Jupyter Notebook. And then we have to use the right solver, which I'm using GLPK, which is an open source one. And also ask the solver that I have already defined to solve the instance I've created for my problem and print the result. And that's it. This is the only code I'm going to show you in this session, because I feel that the coding part is not the important part. We need to understand the concept behind these codings. So we just need to know, okay, each individual model has some elements which is attached to my model, variable, constraint, objective, name of my model, and so on and so forth. And then pass the whole model to my solver, and the model will solve by the solver. And we can print and display what's inside my solver. And that's it, okay? And you can easily do this with GAMS. This is exactly the same optimization problem in GAMS. Again, you have to define your variables. You have to define your limits of your variables. For example, x1.low is 0, x2.low is 0. You have 3 equations, 2 constraints, 1 objective function, as simple as that. We have to name our model. I just use Pyomo name for modeling the name of my model. So you can choose another name as you want. And I have said, okay, include all the constraints inside my model, and then solve my Pyomo using linear programming, maximize OF. Here, I didn't specify the solver name, because the way you specify it in GAMS is you have 2 options. You can write it down as a line of code. You can say use, for example, Cplex for linear programming, or you can go to a table in the options section of the GAMS and indicate each individual optimization type should be solved with different specific solvers, okay? And then after the solver statement, you can display the content of your decision variable as well as the objective function. So you see the concept is exactly the same, but the concept between the GAMS and Pyomo is somehow different. It's been so long time that GAMS has been working. If I'm correct, it's been about 40 years, even more, that GAMS has been is being used in the market. Okay, it has a very great support. It is capable of communicating with different type of solvers, open source ones or commercial ones. As I said before, even if you are using GAMS and you are only using open source solvers, you still have to pay for the license of the GAMS itself, because it's capable of talking to that open source solver, you know. So but the good thing about the Pyomo is that although it is capable of communicating with less number of solvers, but most of the time those little number of solvers are capable of handling your optimization problem. So there's not a big difference between the use of them. And if you are familiar with any of them and you have the license for any of them, then you use them, okay? So the most important thing is that what type of question you are going to ask. So some examples, some beautiful examples here. So this is the map of the Ireland. You can see there are different counties in Ireland. The question is, if you want to paint the county in a way that no 2 adjacent counties are painted with the same color, this is the result. Maybe you have seen different maps and this is happening in them. This is another application of the optimization modeling. Another application is in the aviation industry. You see there are multiple number of airplanes in the air rotating around the control tower of the airport. So the operator needs to decide which one should land first and which one next, in order to make sure that they will meet their target time. And also there is no latency or earliness penalty for each individual airplane. So the problem seems to be very easy, but in reality, it's not very easy, because we need to make sure that each airplane is specify a specific time for landing. And we need to make sure that between the yellow and blue, which one should land first, okay? So we do have some binary variables saying that, for example, uij. So uij, if it's 1, it means that I should land before j, for example. Okay. So let's go forward. There is another application of the optimization, which is the vaccine center allocation. So we do have lots of places for allocating the vaccine center, for example, and there are many people around the country that they need to be served. Okay, so the question is, we do have a limited amount of budget. How should we allocate these centers in a way that this is done at the minimum cost, and also the coverage of different people are maximized? Okay, this is another application of the optimization problem. And also, finally, this is the last, I think this is the last example of non-power system application. So look at these metro map designs. So I'm sure that you have seen many of them in your life. If you go to different cities around the world, like Paris, like London, or any Washington, New York, or whatever, you can see these maps. So in designing these maps, they have used the optimization. But how? So there is something similar in most of them, and it's the fact that they are only using the horizontal lines or vertical lines or 45-degree lines, you see? So the question is, I do have multiple number of nodes or train stops or metro stops. And the question is, how should I allocate them on the surface in a way that they are located in this specific way? So no two nodes will create, let's say, an angle other than 45 or 0 or minus 180, okay? So this is another application of the optimization. So if we go to the power system modeling, back to power system modeling, this is very simple. So the basic equation that will drive our power system modeling is the balance between the consumption and generation. So at each individual node, we do have some PG generation. Maybe we do have some battery, which is modeled as the P discharge of the battery. We have some Q generation, reactive power of generation. And also we have some demand, some charging of the battery, or Q demand here. And also we have some flow to the neighbor nodes. So we need to make sure that the, as I already mentioned, YAMS or Pyomo do not understand the power system or any kind of engineering, okay? So we just need to write down some equations saying that the summation of what we insert to that node is equal to what we get out of these nodes. This out of means that, for example, flow to the other nodes or consumption at that specific node, or charging power that is needed for filling or battery, okay? And also we need to make sure that we are following the limits of our decision variables. So for example, PG here is the generation at the bus I at time t, and this specific variable, which is representing the output of my generating unit, should be always between P min and P max. Also, the balance of the active and reactive power should be observed at each individual node. As simple as that. So we are writing the KVL and KCL laws, and we pass them to the Pyomo as a constraint. So if you want to see more resources on the GAMS, this is my book. And also if you download the GAMS, if you go to the model libraries, you can see this specific library, which contains several models that are freely available to you, which includes, for example, economic dispatch, dynamic economic dispatch, multi-objective optimization, environmental constraint, economic dispatch, and so on and so forth, as well as the DCAC OPF. So you feel free to modify them and use them in your application. So you can definitely do this in a better way, but this can be a good start if you want to start the coding. So let me show you what type of applications we have solved, and we have used them in our publications, for example. So here in this publication, we did a very nice study, and we were trying to find out if we are able to put some fax devices on the 118 bus system. And these fax devices can be working on inductive mode or capacitive mode, or both inductive and capacitive, sometimes inductive, sometimes capacitive. Where should be the optimal locations of them in a way that the transmission system operator is sure that it can supply the demand, even if they don't know the exact value of the demand. So this work included the uncertainty modeling, included the optimization, and included the asset allocation. So we were trying to find out the optimal allocating of these fax devices in a way that we want to increase the resiliency of the power system against the uncertainty of the demand. Another piece of work that we analyzed was related to how to extract the hydrogen from the power system. So these days, if you are aware, the topic of the green hydrogen is very hot. So it means that, for example, in Ireland, every year, according to the report published by Transmission System Operator, a large portion of the wind is curtailed. It means that some portion of the wind is not capable of being injected to the grid. Why? Because of the stability issues, because of the line flow issues, security issues, and also lack of enough demand. So Ireland is an island. So it means that if it was well AC connected to its neighbor countries, we didn't have this much problems. Okay, so at the moment we are connected to UK and France, if I'm correct, with the DC links. So it means that if something related to frequency happens in the system, it cannot be resolved by the connection to the other countries. Okay, so the inertia cannot be transferred from those countries to Ireland, for example. So this means the penetration of non-synchronous generation, which are in this case wind turbines, should be limited to some level to avoid frequency and stability issues. Okay, so a large portion of the wind is lost. It can't be injected to the grid. But the question we asked here is it possible to somehow increase the demand in the system to be able to absorb this amount of electricity, run our electrolyzers, and create hydrogen? For what purpose? It can be used for different purposes. For example, fueling the future aviation. We did a nice study here to investigate, is it possible to fuel some specific air route in Europe? For example, one of the busiest routes is between Dublin and Heathrow Airport. And we investigated to see, using the available assets in Ireland, is it possible to fuel such a specific route or not? And the results were amazing, because we showed that using the available wind in the system without the need for upgrading the system in terms of putting new transmission lines, it's possible to put some electrolyzer in the system and create green hydrogen for fueling these future aviation industry. Because as you know, in the next upcoming years, up to 2030 and 2050, the aviation industry should go to a huge change in terms of the emission reduction. And if they can't do it, it means that their activities will be limited. Okay, so they are trying to find out some alternatives for their fossil fuel options at the moment. Okay, so if you see Airbus has provided some conceptual design for the future hydrogen-based airplanes. So this is the power system engineers who should find out the solution for that. They should be able to find out, is it possible for the existing assets to provide the required fuel for such a huge industry or not? And we showed that in this specific case, it's possible. But of course, this is case dependent, this is country dependent, and based on each individual power system, we can answer this specific question. The other question is, as I already mentioned, is the TSO-DSO interaction. So we know now that these days, lots of distributed energy resources are being connected to the distribution network. It means that the characteristics of these distribution network will change. And it means that they are no longer a passive load for the upstream network. So whatever we put here, like electric vehicles, like heat pumps, like energy storage devices we put on the distribution side, will influence the operation on the transmission side. Okay, so we try to find out the answer for this question. Is it possible to optimally allocate these devices and use their flexibilities to have a better operation for our transmission system? So we model the interactions of these two systems using the optimization tools that we developed. Also, another topic that is interesting is using the trying to figure out how gas network and electricity network are interacting with each other. So traditionally speaking, it is always assumed that the gas network is always capable of supplying our electricity side. But what happens if there are some contingencies happening on the gas side? And also, is it possible to inject the excessive amount of energy that is available on the electricity side and put it back to the gas network and store it right there as the natural gas? So as I said, if we can use the electrolyzer, we can separate hydrogen from oxygen, we can create H2, and then combine it with some carbon capture technologies, and we can create CH4 and inject it back to the gas network. This way, we are using the gas network to store or electricity. This is the most expensive and difficult things to do, storing the electricity. But gas networks are right there. The assets are available right there, and they can be used for huge storage of the electricity. So, and we published the results of this. And we published the results of this study in this paper. I'm trying to change the location of this. Okay, I can hide it. Oh my God. Okay, so you can see the name of this publication. If you are interested, you can go and have a quick look at that. So it says gas networks impact on power system voltage security. So if something happens on the gas network, we will be investigated what is the impact on the electricity side. Okay, these are all done with the optimization tools that we developed using GAMS or Pyomo. Another interesting work is the modeling of the uncertainty. As I already mentioned, GAMS or Pyomo are not capable of doing any kind of engineering. So whatever you say, if you want to see if is it possible to model this specific problem in Pyomo or GAMS, you should be able to answer that. Is it possible to describe it mathematically or not? If the answer is yes, then it can be modeled using any of these tools. So here we try to find out when we put some energy storage on the distribution network and some electricity prices are into action, is it possible to optimally allocate and operate these energy storage device on the distribution side in a way that the payment for the losses and payment for the energy that is purchased is minimized? Sometimes some research works are trying to find out the minimization of the losses, for example, in the system. But at the end of the day, sometimes the electricity prices are not that high. So it's no harm if we increase the losses in those specific time periods and reduce the losses in the time periods that the electricity prices are high. So we did some kind of price-dependent optimization, and we did the analysis in a case that we are not very sure about the price values. So we did this study on the uncertainty of the electricity prices, and we modeled a robust optimization framework in these papers. So there are lots of things can also be done in Pyomo as well. Whatever you can do in GAMS, you can do it in Pyomo. So here you see IEEE 24 bus network. So we can easily calculate the shortest electric distance between each pair of nodes. So what is the application of it? So it means that if two nodes are electrically close to each other, it means that if something happens to one specific node, the same thing will happen to the nodes that are very close to it electrically, not geographically. Okay, so identifying the closed nodes will help us to better identify how to protect our electricity network from different threats, physical threats or man-made threats or different other things, and improve the security and resiliency of the power system. Or we can easily do the security constraint OPF on the larger scale power systems and identify the lines that are at the risk of getting overloaded. So these lines can be easily identified. We can also identify the utilization of different lines in the system. We can find the average, minimum, maximum, and also in the case that n- contingency is taken into account, what happens to the system, what happens to the maximum loading of each individual lines. So there is something interesting here that says, okay, so the maximum loading of different lines is only 4% of the time period. So if you run your analysis for this specific network, it says only 4% of the time periods, for example, you consider 8,760 hours of the year, only 4% of these time periods you will experience 100% loading on that specific one. And this shows you a huge potential for improving or increasing the utilization of your transmission assets. You have spent a lot of money and installed a transmission line between 2 points in the system, but this analysis shows that only 4% of the time you are using these assets. Okay, so there is a huge potential for improving these numbers. And also there are more that can be extracted from this study, and it's the case that you can also identify which of the transmission lines are moving together. What does it mean? It means that, for example, the utilization in some lines are more than the others. We can identify and cluster them based on their utilization pattern. Okay, so once the optimization analysis is finished, we can easily pass it to some other packages that they can do the clustering or different other kind of analysis or data analytics on the available data that is obtained from the optimization problem. So this is what we did here. So here it shows you that if we have 4 classes. You see there are 4 different classes here, and the different classes are identified with different colors. So you see, for example, these red lines will go up altogether and will go down altogether. So the loading of these lines will change simultaneously. So it means that, for example, if the line between 75 and 74 is overloaded, there's a high chance that 69 to 70 is also overloaded as well. Okay, so this is very good for operators to identify the lines that are acting somehow similarly, and they can find some ways to resolve the issue if something happens to any of them. Also, the same kind of a study can be done considering additional constant like n-1, which is very practical in the actual operation of the power system. We need to make sure that if any single element is out of service, the remaining assets are within their safe limits. So we can, again, conduct the same analysis and find the answers. So the good thing about this tool is that I have done this all in Pyomo. And then when the analysis is finished, as I said, I will pass the results to some classifying or clustering packages, and then the results can be used. We can have better insight of what exactly is happening in the power system. So we can identify which lines are loaded simultaneously, and some other information can be also obtained. For example, you can understand. You can understand these type of information. For example, the lines that get loaded simultaneously, optimal maintenance. I don't know why it goes. You can understand that what is the optimal maintenance strategy, upgrade the strategy, the duration of each overload, and other things. Okay, I already explained the TSO DSO. I should have removed this slide, but that's fine. And there are some other resources for Pyomo. There's a very nice book written by the developers of this specific package. And they also have a website. There are loads of examples and documentation you should definitely use. And I personally use Anaconda for running my Pyomo codes, because Anaconda allows you to have access to all the installed packages at the same place, and you don't need to have to be worried about the installation of the different packages, and you will have less problem for using the code. But there are also other resources available for you. So for example, if you want to run your Pyomo codes in Google Colab, which is done by the Google, it's really easy to do. So you can easily put the Jupyter Notebook on your Google Drive, click on it, put some required commands at the beginning of your code. So all the required packages are installed, and then call your model and solve it as easy as you can see. No installation is needed. And also there are some other online resources like Neos server. You can pass your developed Pyomo or GAMS code to this specific server, and it will solve it and send the results via email to you. This is a very cool tool that you can use for your applications if you don't want to install it on your machine, or if your machine is not very high, doesn't have any high spec in your CPU or RAM, whatever. You can use these online free tools. Okay, these are all for free. And this is a very nice implementation of an application of the optimization, and I call it an art because let's wait until the graph is finished. Okay, I hope it's clear who is this person. This is Joker. Okay, so there are 180 nodes around this circle. And the question is, if we want to connect the right nodes together to create this figure, how should we do that? Okay, so for example, if we have 180 nodes, each node can be connected to 179 every other node other than itself. And if I is connected to J, then means that J is also connected to I. So multiply by half. It means that there are 16,110 number of lines that can be drawn here. But which one of them should be drawn? If I had only 4 lines, 2 to the power of 4 lines will be the combination of the number of combinations that we can create these lines. Okay, so 2 to the power of 16,000 will be 10 to the power, around 10 to the power of 4,833. This is a huge number. Okay, so if you want to write it down, it means that you need to write a 1 and 4,833 zeros in front of it. And if the length of each zero is only 2 millimeters, then it will be the length of 10 hurling sticks, which have around 96 centimeters long. So this will be the length of that big number. So you can see if we want to create this picture, we have to decide among these combination of the drawing the lines and find out the optimal lines that should be drawn to create this figure to be as close as to the picture we are targeting. Okay, so I hope I haven't talked much, and I would like to give you the opportunity to ask your question.
Thank you. I'm checking some questions. So here are some questions like, okay, what is the key area in multi-energy system for flexibility applications?
So I showed you one of them here. So that was the integration of the gas and electricity network. So we were trying to find out, is it possible to use the gas network as the energy storage phenomena for our electricity network? But these days, there are more than that. So for example, electrification of the transportation, electrification of the heat sector is also another key that is that should be taken into account, and find out if we electrify all the cars in a country, what will happen to the electricity system? Is the electricity system capable of handling these huge electrification action or not? Because in different European countries, for example, they are trying to reduce their carbon footprint by 2030 and 2050. And this means that there are lots of policy ongoing to encourage people to electrify their home and electrify their transportation. They are asking them to put solar PV on their rooftops. So if all of these happen, is it possible to handle it with the existing infrastructure or not?
Okay, here are a few questions. So I'm reading then here. If utilization curve is not upper than 1.0, there is not probability of trip that line.
Could you please repeat your question? So if your utilization is not more than something, it means that there is no risk for trip. Is that right?
Someone asked that if utilization curve is not upper than 1.0, there is not probability of trip that line.
Actually, so the research I was talking about here on this slide was somehow should be very informative. So let me bring it here. For example, So actually, we are trying to find out the utilization curve of different line in the system. Okay, so we already put the maximum equal to the to the limit of each line. Okay, but the question is here that most of the time, let's say 96% of the time, the lines are not utilized at their maximum value. I understand that it's not very good to reach to the maximum limit. I totally understand that, because operators are always setting a kind of threshold before reaching to their limits. But at least, for example, they say, I'm not saying that we have to bring this orange curve to 100% for all the time, but we can also bring it to 75%, for example. Okay, this is why the importance of this issue is that, okay, we do have multiple lines in the system that are not very well utilized. It means that there is some room in these specific lines to be to increase the loading. If we don't do that, what happens? We have to install new transmission lines, okay? Because sometimes in the system, the load grows or the connection of the new generation will increase. This means that we have to, the technical constraint in the system will tell us that we have to put a new line in the system, which is not very easy to do, okay? Because public acceptance doesn't allow us to easily install new transmission line in the system. But the alternative way is it possible to better use the existing assets? Or I should ask it this way, is the existing asset capable of handling more loading before we enter any dangerous kind of a state or not? This study will show that.
Okay. Here, someone asked about what is the potential of P2G, he mean power to gas, plus carbon capture systems in enhancing the gas grid and hence power system flexibility.
So actually, this is the study that we did in our IEEE power system paper. And in that specific paper, we showed that, okay, if we have excessive amount of wind, then is it possible to inject it back to the gas network or not? And the short answer is yes. And we showed that with this action, we can save a lot of wind every year. This is bringing us some money. And also the security of the power system is better identified and evaluated. So we don't simply assume that the gas network is always working and is always capable of supplying us. So identifying the risk is done in that specific paper. I would suggest you to have a quick look at that research, so you might find better answer to your question.
Okay. Here's one other question. Which learning curve is greater, learning games or Pyomo?
Uh, it totally is dependent on yourself. So if you know GAMS, you can easily learn Pyomo. If you learn Pyomo, you can easily learn GAMS, okay? There is no big differences between them. So both of them are creating a model. They will attach variable, constraint, parameters to the model, and then pass it to the solver, okay? So the good thing about that is you don't need to exactly know how solver is solving that big optimization problem. The only thing that you need to make sure is that you should be able to correctly write down the constraints and pass it to your model. So I can't give you an exact number. I can't say this one is 2 weeks, the other one is 1 month. So both of them will need some equal amount of timing. So I think I answered the question.
Okay. Here's another question that is there any good source for optimization choosing algorithm?
Optimization choosing algorithm?
Yeah.
I'm not sure if I understand the question correctly. So, so there are different algorithms for solving different types of problems. For example, if your optimization problem is a linear one, usually the simplex is the methodology that is used for solving the problem. And the different solvers are implementing that specific algorithm. Okay, this is not something that you define. Okay, or sometimes you do have a nonlinear programming. So gradient-based methodologies are used for solving nonlinear programming, and each individual solver has its own methodologies to implement that technique to the problem. And sometimes you do have mixed integer nonlinear programming, which is a more difficult one. So Bender's decomposition is used for tackling these type of problems by assuming some values for your binary or integer variables, make the problem nonlinear, solve the nonlinear, get feedback, and update the integer or binary variables, and iteratively improve that until you converge to some point that you don't need to update any other variables. And that point is the optimal solution for your application. So we can't give you any specific algorithm to select the optimal algorithm,
He asked again, while choosing the optimization method, how to be sure that we are not overkilling the problem while solving.
We are not doing what?
We are not overkilling the problem while solving.
What does it mean exactly?
Actually, the question is not clear. He didn't ask clearly, but he is asking like while choosing the optimization method, how to be sure that we are not overkilling the problem while solving.
Okay, so the precision of your decision making and optimization modeling is dependent on how you clearly describe your optimization problem. So sometimes, for example, let me clarify this way. So you want to solve the optimal power flow. So one way of tackling this is using DC optimal power flow, which is a linear one, and it can be easily solved using linear solvers, and it is capable of being solved by larger scale even power systems. Okay, but the problem of DC OPF is that it's not very realistic. Although it's very fast and it's capable of handling larger scale power system, but it's not very accurate. You need to use the AC power flow. But at the same time, if you want to solve a multi-period AC OPF for multiple number of time, then it will take a lot of time. So depending on your application, you need to choose the right solution for that. So for example, what they do in, let's say, practical applications in the TSOs, they simply run the DC OPF. And if the problem shows any kind of problems, then try to resolve it. If any a specific time period needs more investigation, then they will pass those specific time periods to AC power flow. So this is not something that can be done automatically, So it all depends on your problem you are talking about.
Okay, thank you. Another question is it possible to model MPEG problems by Pyomo? MPEC.
Yeah, MPEG problems. So in these specific problems, you do have, let's say, multi-level optimization, as I discussed before. Yes. So when I say yes, it takes more time to implement it. So, but how? When you have multi-level optimization problem, you can transform your optimization into a single level one. But this means that you are making your problem more difficult, means that you are making it nonlinear. That's fine. If your solver is capable of handling the nonlinear constraints, then it's definitely doable. But if you say, is there any off-the-shelf methodologies to just pass a multi-level or MPEG problem to Pyomo? At least I haven't seen that, but it's doable in GAMS in a straight way. But if you want to do it in Pyomo, it should be simple, but because you need to convert the lower level optimization problem and bring it to the upper level and create a single level optimization and then solve it. So everything is possible. It depends on how much effort you put into it.
Okay. Here's another question. Which source of power, according to you, is going to be used to support renewables once we try to away from coal?
So there are different resources available right there. So actually, the nuclear is one of them because it's stable and it can provide inertia. And it's very difficult if you want to go 100% renewable, because usually the renewables like solar PV or wind turbines are non-synchronous generations. This means that they can't handle the inertia issue. That will create lots of frequency issues for the system. So we do need some resources to provide us inertia. Okay, so for example, hydropower is capable of doing that. Nuclear is also capable of doing that. Some other methodologies like let's say synthetic inertia is also capable of doing that. So there are different methodologies that are being investigated here these days, and specifically in the countries with some specific geographical characteristics like Ireland. These type of studies are very relevant, and we try to make sure that you are capable of handling more and more renewables in the system. For example, at the moment, you might see more wind in the Denmark compared to Ireland, but Denmark is very well AC connected to its neighbor countries, unlike Ireland. So in some countries like Ireland, it's much more difficult to increase the penetration of renewables. They are using different kind of services, and we call it DS3. We try to find out, is it possible to provide flexibility and ancillary services to support the increased penetration of the renewables in the system or not, like demand response, like synthetic inertia from different units, and different other things to support the increasing the penetration of renewables in the system, specifically the non-synchronous one.
Oh, he's asking, like, nuclear plants have ramping issues in order to support net load variations. Which source are more important? Can gas networks fill the gap?
So the ramp rate is a very important issue, specifically when we do have lots of demand resources that are changing and fluctuating their demand needs. And also the gas network are very important here because the gas units or thermal gas units in the system, in the power system, are capable of providing high ramp rates in the system. If they are not working very well, or they are disconnected from the network, or they are retrieved from the service, then we will face lots of difficulties regarding the ramps. And also in the systems that we do have high levels of the renewables, like wind or solar, there is a high chance of dropping the generation from one time step to another one, because the wind or solar will change suddenly, and we should be able to cope with these changes to keep the lights on. Yeah, the short answer is yes, because the gas network is a very well source to supply or ramp needs.
Yeah. And one question is, does Pyomo has interface to multi-objective solvers?
There is no multi-objective solver available, not in GAMS or in Pyomo. But if you ask me this question this way, is Pyomo capable of solving multi-objective problems? I say yes. So there are, as I said, these tools are not capable of doing anything specific unless you specify the mathematics behind them. So if you have heard the methodology called the epsilon constraint, so this methodology is easily implementable in Pyomo. So you put one of the objective function in the constraints, and you say my objective function 2 is less than an epsilon, then try to maximize the other one, and you gradually change the epsilon value to find all the Pareto optimal solutions that you want to have. And then finally, you can choose the right solution among these Pareto optimal solutions.
All right, that's for today, and no more question here.
Okay.
Thank you very much, Dr. Alireza,
You are very
for
welcome.
giving us time, and it was a very nice session and very fruitful, and we learned a lot from you and the audience. Also, thank you very much to everyone who joined and who asked the questions, and hoping to see you in the next session in the future. Thank you very much.
Thank you very much. Have a good day, everywhere. Bye-bye.
Bye. Thank you very much.